Hey, what's up, guys? Catlin here, and I think for some reason, there it is, video wasn't showing up. We've got a new set of homework problems this week. Lesson 18 is where we're starting. And the first problem wants you to take every expression that's there and write an equivalent version, which means it has the same value, but just using plus. So only addition is going to be involved. See how they got some minuses strung throughout each one. So we're going to rewrite them as plus versions. So what I'll do here is we'll do part A first, and I'll show my work as I go. All right. So if I want to take expressions that have minus problems in them and rewrite them with only addition, then we're going to have to use one of our rules that we learned back in Unit 5, which is add the opposite. Any subtraction problem can be changed to an addition version if we add the opposite. So we could do something like this at the very beginning. We just take every subtraction, make it into an addition of its opposite that follows, like such. The minus 7 became plus negative, and the minus 9 became plus negative 9. And now we can move things around and combine them however we want to. Technically, we could leave it just like that if we wanted to. We don't have to go any further than that. But I assume they probably want us to simplify it. But actually, no, it doesn't say simplify. It just says write an equal expression that uses only addition. So I'm stopping there. Less work for me, right? Let's do part B. 4x minus 7y minus 5z's plus 6 could be rewritten as adding the opposites. Instead of a 7y, we think of this as adding a negative 7y. Instead of a take away 5z, we think of it as adding a negative 5z. And then the 6 doesn't change because it's still added. All right, and lastly, let's do the C part. Negative 3x minus 8y minus 4 minus 8/7 z. Don't let the freaky fractions get you intimidated there. We're just doing the same thing that we've been doing, which is adding the opposite. That's all we're practicing here. Taking away expressions is the same as adding their opposite versions. Minusing 4 is the same as adding a negative 4. And minusing this 8/7 z is the same as adding a negative 8/7 z. And there you go. That expression, all of these expressions on the bottom are equivalent, and they have only addition in them, no subtraction. Just a bunch of negatives now instead of having subtraction. Number 2 is a big set of practice problems for distributive property. All right, so we're going to have a lot of work here that needs to be shown. Part A, let's jump right in. We've got 9 multiplied by the group of 4x's, take away 3y's, take away 2/3. And for every one of these, we're multiplying the number that's outside by every one of the terms that are separated by plus or minuses inside the term, inside the group. So, for instance, on this first one, let me do an example on this first one that we did in class, which is to use the area of a rectangle. And I'll only do this on the first one. All right, so 9, we could think of this as 9 being multiplied by 3 different sized rectangles. A 4x, a take away 3y, which is negative 3y, and a take away 2/3. And the area of the entire thing would be the same as multiplying 9 times all of that stuff being subtracted. So our answer would be every one of these expressions on top multiplied by 9. So for example, 9 getting multiplied by 4x's, 9 getting multiplied by negative 3y, 9 getting multiplied by negative 2/3, 9 times all of them. And this can be simplified. You know, if I've got 9 groups of 4x's, I've got 36x's. If I've got 9 groups of negative 3y's, then I have either, you can think of this as a takeaway 27y, which is the way I'm going to write it, or adding a negative 27y. Either way that you want to think about that. And then 9 times 2/3. Well, 2/3 of 9, if you break 9 into thirds, it's 3, 3, and 3. If I keep 2 of them, that's 6. So this would be the same as minus 6. I'm getting the 6 by multiplying 9 times 2/3. and that's part A. Okay, let's do part B without the rectangle. Okay, so the problem is negative 2 times negative 6x plus 3y minus 1. So we're going to see that the negative 2 gets multiplied by negative 6x. Plus comes down. Negative 2 gets multiplied by 3y's. Minus comes down, and negative 2 gets multiplied by 1. Okay? And everything gets multiplied here. So negative times a negative here. If I've got two groups of 6x's, that means I've got a total of 12x's. Two groups of 3y's. That's the same as having 6y's, but a negative times a positive is negative 6y. And then negative 2 times positive 1, subtract a negative 2. And we can simplify this even further and just write it as 12x's minus 6y, kind of undo the add opposite there. And taking away a negative 2 is the same as plus 2. Actually, I would accept either of those last two since they essentially mean the same thing. Okay, on part B, I'm going to just write down my first step instead of the original problem. So 1/5 is going to get multiplied by 20y minus a fifth is going to get multiplied by 4x minus, and a fifth is going to get multiplied by 13. A fifth of 20 is the same as 20 divided by 5. All of these are just division, really. 20 divided by 5 is 4y's minus 4 divided by 5 is 4/5. 4 divided by 5. Duh. And 13 divided by 5, or a fifth of it, would be 13/5. And that would be my answer. I can just leave it like that. Some of you are going to try to make that one harder than it really is. Okay. And for D and E, I'll let you try those out on your own. And you've seen some examples here of how it works. But show your work on D and E for yourself. If you have trouble, you can ask me personally. Let's look at number 3. Kieran is saying that the expression x minus 10 can help solve this number puzzle that he's written. Pick a number, add negative 2, and then multiply by 5. Lynn thinks that Kieran has made a mistake. How can we convince Kieran that they have made a mistake? So we can convince them by proving that his expression does not work for the puzzle. That would be what I would do. So let's so we can convince him by proving it doesn't work. Okay. If, let's say, x equals, let's pick an easy number, 20. Okay. If we pick a number like, actually, let's go easier than that. Let's pick a number like 10. Let's say that x equals 10. Well, according to his expression, 10 minus 10 should be 0. So when they get done with the number puzzle, they should get 0. Well, I've picked my number. The puzzle says to add a negative 2 and then take that and multiply by 5. So adding negative 2 gives me 8. And then multiplying by 5 gives me 40. 40 does not equal 0. So that's proof that it doesn't work. I think what Kieran was trying to do was to take his number puzzle and rewrite it as a different expression, but forgot some parenthesis groups. So let's look at and see where he messed up. So if you pick a number, you can call that x. If you add a negative 2, that looks like this. But you want to multiply this entire thing by 5. And I think what Kieran did is he only multiplied the 2 times 5. I think that's probably what happened. He really wanted to multiply everything by 5. So that would look like this. This is his number puzzle in expression form. And what he was trying to do, I believe, was distribute, but he forgot to distribute the 5 to the x. So instead of x minus 10, he should have gotten 5 times x plus 5 times negative 2, which would be the same as, write it up here, 5x's plus a negative 10 because 5 times negative 2 is negative 10, or 5x minus 10. So if he takes his number, multiplies it by 5, and subtract 10, he should be able to do the same thing that the puzzle is saying. And it works. Let's try our number 10 out. 5 times 10 is 50. 50 minus 10 is 40. And that's the same thing that we got when we did the number puzzle the regular way. So we know that it works. So this would be an expression that would represent his number puzzle. And that's the first page of your homework.